the stream. Let's close some distractions like mail, Microsoft Teams, Messenger, yeah, Discord, Spotify, sure. Okay, now we got the distractions out of the way. I just want to find the reference video. I forgot to save it yesterday, I think. So where is the reference video? Oh, here it is. If I can find it like so. I posted it on LinkedIn. There is I'm just gonna make sure this is turned off. Yeah, it's turned off. I just want to find the reference video before I start. I can maybe open the model from yesterday. In the meantime, there we go. And here it is. But how do I view the original? Yeah, that's not mine. But it's not the original. Can you hear the music? All right. So this is what we're aiming for. We're aiming for this thing. I guess it's kind of small on your screen. Like so. So this is what I want to create. To have the robot slide along the floor track and pick up bags 3x3 and drop them in the orange container, and it looks like it's always dropping the rightmost bag first, then it's dropping the leftmost bag, and finally it's dropping the center bag. So I wanna reach this particular detail level, so it's gonna look exactly like in the video, more or less. And maybe we can also add that guy standing there. He's probably making sure everything is safe. The workplace is safe. It's very important. Okay, so here we go. Now we're back in Visual Components, and this is where we're at right now. I click play and it crashes. It says the generic robot position is out of reach for that robot. That is the darnest thing. But I have actually cheated, so I did some homework since yesterday. I found this method, joint. Oh, I still get the Outlook. Why? I thought I closed my Outlook. Let's see. Outlook. Mail. Let's see if we can close the mail process. Yep. Joint move to component. It can actually, you can provide a component and then you can tell the robot to go to a frame inside that component by using the toFrame. So let's try this one and see, because the issue we got yesterday was that when I made the robot program in programming tab, I couldn't figure out how to not move the floor track and program those points as part of the program. I don't know if it makes sense. You can watch the stream and see how I failed. So today I am well rested. I slept very well and had some nice breakfast and a shower. Drop the kids off on kindergarten. So let's go. So it's crashing right now here. It's trying to do a linear move to a position that is out of reach. But we're going to use joint move to component. I'm going to pick the robot itself. And then say to a frame that we made yesterday inside the robot. We have the pick here and pre-pick. So pick and pre-pick. They're here. I want to navigate to those. So to frame could be pre-pick. And then I want to go to pick. And let's see if that works. Whew! It's doing stuff. It's dancing. It has broken itself. And it seems like the points are upside down to what we want to accomplish. I want it oriented this way. So I'm going to go to the pick and reset these points rotations and just watch it again. Okay, so it's turning around and it's going like that. Cool. Seems like we need to just rotate it 90 degrees and lift it up some. So these 2 points, let's move them up and individually give them a Z rotation of 90 degrees. Let's watch that. That looks good. Let's speed the simulation up, reset, move them down a bit. Then we end up here. I want to move it down just a bit more. I'm not being super accurate. I'm only using my eye to measure. Looks good enough, I think. So now we can actually get the robot moving, and this is what I tried to do yesterday. So mute my stream and just have my stream open so I can watch the chat. If anyone out there is an experienced streamer, please provide any feedback to make this stream better. Today I have decided to stand up, so I've raised my desktop and now I'm standing up. Maybe that will be better for my voice, I think. That's what I hope, at least. Okay, the chat room. I have at least someone watching. That's nice. Maybe I should zoom in the code a little bit to make it more readable in the stream. So, now let's watch this slowly to see where we're at. So it goes to the pre-pick position and then it goes down. And as I remember, I think the bags start coming at like 18 seconds. Okay, it's more like 26, 7. So I'm gonna put that time in so we can start looking from here and then see what happens. So they go in and they stack up next to each other. And this actually looks pretty good. I think the robot is a bit quick. And I want to move the pre-pick slightly higher. And I want to use the pre-pick position when we want to do the task. You pick the 3 bags and then you turn 90 degrees. Before you turn 90 degrees, I think move vertically up. So move up to the pre-pick, and then I don't want to do a joint movement, I want to do a linear movement. And then we drive the first joint to the value 180. Okay. And then we add physics to the bags. And here is where instead of doing it in a for loop, so you're actually giving the physics to the first bag, the second bag, and the third bag. Remember in the video, you were dropping the outermost bags first and the center bag last. So I'm just going to code that in. So what does it look like? You're doing this for the bag, and the bag is actually located in bags. So I'm going to remove the for loop. Now I'm going to keep the for loop to have the container grab the bags. And then I'm going to add the physics afterwards, because this for loop just allows the orange container to grab the bags. So I want to do that first. So I'm going to add that in the comment. Orange container grabs each bag. And then we drop the bag, and then we use the bags list. So we want to drop the outermost bag first, and then wait a bit. So let's see if that is the outermost bag. And then you drop the one on index 2, and lastly you drop the one in the middle. And you do this with a small delay in between. So delay 0.25 before you start doing this. And then delay 0.4 in between doing this and afterwards. So at 37, and it turns out it was a wrong order. So the order should be do 1 and 0 like that. Go up to 37, and let's watch it again. Now we drop the center one first. Is this not always center? Oh yeah, I think I made a mistake. So should this be 2, and then drop the 0, and lastly drop the 1, the 1 index. Yeah, that looks good. And it's actually working. Although it's not working because even though I move these guys, I move them, and then I believe retain, and I never move that interface. So maybe if I move that interface as this interface also moves, because I have retain offset activated on the paths, I can show you what it looks like if I just turn off retain offset on the path. Retain offset turned off. That means that everything that is entering this path will be teleported to where the path actually is. And then we see that they get teleported from that interface, it's entering that path, and then it works as expected. But sometimes the robot is going the other way. I can probably fix that, but let's not focus on that. Let's focus on getting the bags. So let's see if we can have this triangle, the green triangle, move along over here. So somewhere I am adding, somewhere here we are moving the robot with the bag width. That would be drop the bags, position the robot for the next bag to drop. Here we use a servo. And here we're always adding a bag width. And here, after we have moved, we want to tell the other conveyor down here, hey, we actually moved. And this conveyor down here is called bottom conveyor. Do I have the bottom conveyor? No. Let's just find it. If you think I'm doing it a bit slow, it's because I'm trying to think ahead a little bit, seeing what we might run into issues wise, but yeah, you can't predict everything, so let's just try. So the bottom conveyor, I have that now, and I will add a property onto the bottom conveyor. I'm gonna call it an recog offset. And each time we change that, we want to rebuild. Maybe we need that in order to update the path. So I'm going to keep rebuild true here. And so the recog offset, the bottom conveyor dot recog offset should be initialized as 0. And then each time we make a move, we just add the bag width to the recog offset. And now we will use the recog offset to translate that triangle, that interface frame. The frame, the end frame. Here it is, the end frame. So let's do TX with the recog offset. I could have just used the conveyor end offset. I forgot about that one. So this is the way forward. So let's just see now. If we change the recog offset to be 250, I saw that it moved to be times 2 plus 5, and it's moving. Cool. If we just run, it moves back. It seems like the interface is moving along. I wasn't sure about this, but that's beautiful. So each time we move the robot, the interface follows. Cool. Now the robot is doing some funky stuff. He needs to go over the... Yeah, he needs to go over the side. So it's probably that I'm driving the joints to a value of 180, and then when I'm moving him back, where am I controlling the robot? It's probably up here when I use this to move to the pre-pick, and the joint move sometimes, since we're actually on the edge on 180, it's sometimes finding the wrong way to go back. So maybe I can mitigate this. And instead of drive joints, I think there is a relative command. So joint move relative. Executes a joint movement. Are we now looking on the robot? Yeah, we're looking at the robot. Joint move relative. So executes a joint movement relative to the current pose. The joint move relative. But I want to drive the joints. Drive joints. Drive joints. Here we can affect the joints. Is there anything else that can affect the joint? So joint 1. There is a boolean for relative for drive joints. So relative should be true. So I want to do that, and relative is true. Relative is true. Then I probably want to do 90. And then after we moved everything, do relative minus 90. Let's see how that works. It didn't like the relative. Hello William, Cheesy, Andreas, let's say for nice. Hello dude. It's good. I'm getting close to doing my robot application that I set out to do yesterday. But the boolean also maybe I should call it J1 so I don't mix. So J1 is equal to minus 90. And same here then, J1 is 90. Let's see if that works. Drive Jones got an unexpected argument in J1. Alright. So what if I just do this? 90 true, minus 90, true. That works. Looks like. It's just doing the wrong the wrong joint. Can I do J1 and J1? Line 70. Track joints J1 is 90. Non-keyword argument after. That was what I tried before. So it doesn't expect J1, even though the documentation says J1, but how many reels do we have? So we have 1, 2, 3, 4, 5, 6 reels. The motion time, 6, 7 values, a boolean and a reel. So 7 values. So the first one, yeah, but I don't want to drag the other ones. Okay, I'm gonna do this with using frames, just so I'm just gonna use a method that I know works. So pre-pick, the pre-pick, let's call it place. It's the place position, and oops, the place position is going to be roughly somewhere here, and we're going to calibrate this as we go. Now we have a place, so let's drive. So when we do the first 90-degree turn, we want to drive to the place pos, and then back to pre-pick pos. So let's remove those again. All right. Seems to be working, and maybe rotate that point. Oh yeah. Let's see, why are the bags falling around like that? If I can just find the first point, then it should work. So I think there is a small issue with since the bags are stacking up next to each other, and then when I drop them, the collision boxes are square, and then you get this. So if we change the collision meshes of the bags to be precise, maybe it's gonna look better. And then I do a linear move, and then we do a joint move. Let's try linear. Let's try linear all the way, except for the first one. So what I mean with the physics, the chips bag, we created a physics entity on here. No, we haven't done that yet. It actually happens exactly when we drop them. then this got a physics entity. Physics entity, okay. And then it says in physics, collision group, default group, cool. And then I think we can look at the root physics collider to be precise. So I believe we have the feeder over here, and it's using this chips bag. So let's get a hold of that chips bag and pull it in and change the root physics collider to be precise. And then it added a physics entity already. Then I want this to be maybe out of physics. Or kinematic. Let's try kinematic. I don't remember. So I'm gonna save this as a new chips. So chips with physics. Save it. Yeah, sure. Let's put it here. Call it chips version 3. And chips version 3. And this advanced feeder should be looking at chips version 3. So now when we create chips bags, they have a precise collider and they have a physics entity. And now they're about to be dropped for the first time. Huh. This was unexpected. Oh, you're calling it witchcraft. Yeah, it's what you get when you nerd into a simulation tool. And now I understand what you mean by witchcraft, because all the chips bags are actually flying around. Do 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 do. And I don't know why. Maybe it is because it's gotten 2 physics entities. Oh, I don't know what Stephen Hawking would say about 2 physics entities. At least Visual Components makes them fly around like it's been affected by gravitational waves. So let's not create another one. Let's just say, just change the physics type from kinematic down to be in physics, and then I think we're good. So when we add the physics down here, we don't want to do that. So instead of create behavior, let's use find behavior. And what is the name of it? The physics entity. Physics entity. Oh yeah, that's what it looks like. Physics entity. All right. Grab the physics entity, and the physics entity property of physics type. So I think it's called physics type. And I don't know how to change that it could be an integer, so I think it's going to be an integer. We set this to integer 0, 1, 2. But I don't know. I'm just going to try. Nope, the code didn't crash, but the chips, they did not fall, and the physics type is now kinematic. I want to change it to in physics, so I want to change it to 0, of course, and not 2. 0, 0, 0. Here we go. The bags are not falling always exactly as nice as in the video, but I think I'm gonna live with that. It looks more alive when it's not. It looks more alive. Yeah, I'm gonna go with it. I'm fine with it. Because what you have in reality is you have a soft body that's falling and some cushioning and dampening going on. So this is a rigid body. So that is what you get. It looks good enough. Now I want to tweak some stuff to make it look like in the video. Where did I put my video? Where's the video? Here we go. Okay. This is what we're aiming for. I don't know if you can hear the music, but the music is great, so check out the clip. Okay, so it's doing that. I'm just looking at the conveyor speeds. So, are the conveyor speeds matching? Yeah, I'm digging some music. It seems to be the same conveyor speed all over, and the bags are not coming super tight, but yeah, I'm just gonna have a look at it. Oh, the robot is doing some funky dancing. I think the robot heard the song. Oh yeah, it's doing some really funky stuff. So sometimes it's doing the funky. And if I want to post this video, as I would like to, I don't want the robot to be dancing that funky. I want it to look safe. So if you ever wanted to install this robot, it shouldn't be woohoo going all over the place. So let's try and just change the joint movement to be a linear movement and see if it behaves. Is it behaving? So far so good. Yeah, it doesn't look like it's giving any surprises. So I think we finally did it. So how long have I been streaming? Maybe 2.5 hours or something. So if you watched yesterday, there was a big big detour where I didn't investigate how I would solve it, because I wanted to give you the raw experience of just searching, like fitting the pieces together, and then like trying stuff, failing, rolling back, going in another direction, because that is usually what work is like. If you want to create something of value, I believe always a good way is to ask other people, what do you need help with? That's an obvious one. Another principle to use is to break down problems in their smallest pieces, identifying the smallest pieces of the puzzle that we have to work with, and then trying to see, okay, given the problem I want to solve, can I fit these two? No? Break it down further, or maybe change the approach somewhat. So I hope that I gave you that creative journey where I'm quite good in the software. I've been using it before. I've never done this where a conveyor actually moves and you actually move the interface along with the conveyor. That was new to me. So I'm really happy that in Visual Components it just worked. I want to do the same application in plant simulation, and I don't actually know how to get the conveyor attached to the robot and have the interface move along. Maybe it takes a bit more, I'm guessing it takes a bit more programming to always keep track of where stuff is on a conveyor, and then like having it moved by code onto the conveyor, not go via the interface. But I don't know. Could be that I just can't see the solution because I haven't done these machine modeling things as detailed in plant sim. In plant sim is usually slightly higher level of abstraction, in my experience at least, when I've done projects. So this concludes today's stream. Let's just watch it one more time and let's see if I can pull up the video. This is the video. Can we have the video at the same time? Here's the video. Here's the simulation. They're going with an angle. Oh, I need to fix the coloring as a last thing. So that should be yellow. The conveyors should be having green belts, and I think that looks good enough. So usually in the simulation I always go for recognition. So if you're creating something, make sure that the customer can recognize if it's their environment, their factory, their layout. Use the same coloring and try to mimic the layout, and you will give the project better chances of being successful, because simulation is a powerful communication tool. So you're able to showcase how a system should be behaving after it's installed. Yeah. Okay, so if we click reset, play, here we go. It's working! Oh yeah. So, that's everything for today. Everyone, or maybe only Andreas at Seifo, thanks for watching. And this video will be going up on YouTube for reference. See you later.